Okay, now we move on to chapter 2. Simple regression model. It actually means bivariate regression model. Okay, just to start off by telling you the difference between the Gujarati style and the Woodridge style again. I think I can zoom that out a little bit. Okay. In the Gujarati textbook, if we run a regression with only one explanatory variable, we call it bivariate regression. But in the Woodridge textbook, it is rather referred to as simple linear regression, SLR, so keep that in mind. And then in Gujarati, if we run a regression with at least two explanatory variables, we call it multivariate regression. But then in the Woodridge textbook, we rather name it as multiple linear regression model, MLR. So keep that in mind. Okay. And then when it comes to the first 10 slides, I think I will just very quickly go through the slides. I will mainly rely on the study guide, actually. This is the bivariate, oh, sorry, I must stick with the Woodridge style, simple linear regression model, SLR. There is only one explanatory variable. So y explained by x, and then you have the error term, u, or the disturbance terms, which stands for the omitted explanatory variables. I will talk more about the error term. I just want to quickly go through the slides. I think you already know how to interpret the slope parameter, change of y over change of x, and then there are some examples. I don't think I need to go through that. And then the graphical illustration, I think you actually learned it in your undergraduate econometrics. Why is my okay? And then I think I'm a little bit ahead. I have to stop at slide number 10. And then you have seen this slide before way back in your Eco 242 years. So I will also not go through that anymore, self-explanatory. I would rather go through the important stuff on your study guide. So this is the simple linear regression. Okay, again, just a reminder. And then U stands for the error term of disturbance, which represents factors other than X that affects Y. In other words, U stands for the omitted explanatory variables. Now the point is whether we make the right decision to run it as a simple linear regression. I think the answer is usually no, because in reality it is difficult to run a regression with only one explanatory variable. It's unlikely. There should be at least 2 or 3 factors that have some impact on the variation of y. And then the slope parameter, which is in a simple linear regression model, simply change of y over change of x, holding other factors in u fixed. Okay. In other words, in written terms, the slope parameter means a unit change of x has the same effect on y regardless of the initial value of x. This is why you have a linear regression. Okay, graphically. Okay, obviously later we will look at other functional forms like double log and so forth. And then again, just a reminder, it is important for u to be held fixed at all x values so that x has a linear effect on y. And this is the other way to say this. We assume the mean or the expected value of the error terms or the disturbance will be 0. But this will only happen when all the unobservables or the omitted explanatory variables are constant at different x values. That is, the error terms or unobservables are not correlated with x. It still sounds a bit confusing, isn't it? But once I explain the two graphical sketch very soon, then I think you will understand what this sentence means. Okay. And then similarly, we want the mean of the error terms to be 0 on average, and then we also want the mean of the error terms at each x values to be 0 as well. Okay, and then now I want to go through the graphical sketch here. Just focus on the one on the left hand side. Okay, so this is the simple linear regression. This is the ideal outcome actually. Wage as a function of years of education. So simple linear regression model, wage only explained by years of education. U stands for omitted explanatory variables. And then I put 2 examples here, my IQ level and my years of work experience. And then you see this linear relationship between years of education and wage. And then for the x, I randomly gives you 3 values, x equals 1, x equals 3, x equals 5, and then This is the ideal outcome, which is unlikely to happen actually. Okay, we want the omitted variables to be constant on average at different x values. So in other words, it means we hope that when x years of education is equal to 1 on average, the IQ level is 130. And then at the next x value, when years of education is 3, we also want that on average, IQ is constant at 130. And then finally, in the last x years of education equals 5, we also want that on average, IQ level is constant, 130. So it actually means at all levels of education, the mean of IQ is constant at 130. And then similar explanation applies when x is equal to 1, 3, or 5. Then on average, years of work experience is the same, which is equal to 8. Okay, only if all these things happen, then this would eventually happen, that the mean of the error terms at all x values would be constant, or I think it is 0 actually. And then only if these 6 things happen, then we would say there is no relationship between x and error term or omitted explanatory variables. Okay, so this is the ideal outcome. Okay, so let's go back to the written study guide. Okay, the left-hand side figure. Okay, I run this simple linear regression model. U stands for the omitted explanatory variables such as IQ and years of work experience. And if the mean of IQ and the mean of work experience are constant at all x values, then we can say this condition would hold, that the mean of the error term is 0 and the mean of the error term at each x value is 0. Alternatively, we can say that if this happens, then we can say there is no relationship between x and u, or we can say there is no relationship between x and the omitted explanatory variables. But think carefully. Do you really think the mean of the omitted variables? Do you really think the mean of IQ and mean of years of experience are constant or exactly the same at all years of education values or at all x values? I think the answer is no if we really think realistically. So now can we look at the graphical sketch on the right hand side? So this is the reality. In reality, okay, we usually expect when people get more educated, I think the IQ level would increase. So actually this is what happens in reality. When years of education is 1 on average, IQ is 90. When the person becomes more educated, years of education or x equals 3, then on average, IQ actually goes up at 120. And then finally, when x equals 5, it goes up again, then on average, IQ level also goes up to 128. Similarly, the more educated the person is, I think he will be under greater demand in the labor market. Okay, employers, remember in the South African labor market, we demand people who are more educated. Then the more educated people are going to be employed for longer, then they will actually have longer years of work experience. So do you see the upward trend here? So in other words, this condition no longer holds actually. Okay. At each x values, the mean of all the omitted variables or the mean of the u actually is not constant. Okay. Also, this condition no longer holds. Remember, we want no relationship between x and u, but given this realistic outcome, actually this condition no longer holds. In fact, there is actually correlation, in this case, positive correlation between x years of education and the u, the disturbance or the omitted variables, IQ and years of work experience. So in other words, from this realistic outcome or the right-hand side graphical sketch, we actually argue that there is correlation between x and u. Then in other words, we make the wrong decision to run it as a simple linear regression or bivariate regression. Then meaning this SLR, game over. I most likely commit underfitting. Okay, therefore causing the parameters, especially the slope parameters that relates to chapter 3 actually. It causes the parameters to be biased, unreliable. Okay, so let's look at the study guide. Okay, on the right hand side, I think I explained it already. As people become more educated, their IQ level would increase. And as people become more educated, they are under greater demand in the labor market. Therefore, they will work longer and then have longer years of work experience. In other words, this condition actually does not hold. Okay, In fact, we argue there is a relationship between X and U. It means there is specification error in the current SLR. We most likely commit underfitting. So one solution is we rather have to run it as a multiple linear regression model or multivariate regression by including IQ and years of work experience as explanatory variable. So that should be the more ideal solution. Okay. And then I hope that in this new regression or MLR, this disturbance term, so U would have no relationship with X1, X2, and X3. Okay. And then actually, strictly speaking, if I think about this regression more carefully, I still suspect I commit underfitting. Remember, we still have a bit of gender and race discrimination, wage discrimination in the labor market. So strictly speaking, we should still improve this MLR further by including maybe some gender dummies and race dummies, actually. So this is my argument, my further argument to you. Okay, in this multiple linear regression, now I include education years, IQ, and years of work experience. And now for this MLR, the U would include omitted variables, maybe gender, race, even productivity. But remember, it is difficult to measure productivity. Okay. So, and then my argument is that I can still improve the regression further. You see, I should include the race dummies and then the gender dummy. Okay. Okay. But even if I run the best possible regression, multiple linear regression model, there is still bound to be error term existing, or the difference between actual Y and expected Y. Remember, it relates to the concept we learned from the last chapter. Remember that long essay question on why we have error terms? Because of the intrinsic randomness in human behavior. Because wage Y cannot be exactly the same for people with exactly the same years of education. There is bound to be a little bit of variation of Y, even for people to have exactly the same X. Okay, so there is bound to be some difference between actual Y and expected Y. So to conclude, there are two key reasons for the presence of the error terms. This is the first one, the more serious reason, omitted variable bias, due to my poor knowledge of theory. Okay, so most likely we have to run the regression as MLR, multiple linear regression model. The second reason is the intrinsic randomness of human behavior. That is the more acceptable reason for the presence of error terms. Okay, so I conclude the first 10 slides, and then for slide number 11 to 17, it is about the derivation of the sample regression parameters. I'm not going to ask you to do all these OLS calculations. Okay, these two equations, I would just, at honest level, I would just give you the sample regression parameters. Okay, before we go through an example, just to remind you, this is the notation difference, population regression function, actual Y, Y equals that, B0, there is an X missing actually, sorry. Okay, yeah, this is correct. Okay, and then for the PRF, the difference between actual Y and this is the expected Y, given the X is known as the error term. And then for the sample regression function, we have to put a hat, a Y hat. Sorry, this is the actual Y. This is my Y hat actually. The difference between actual Y and Y hat gives me the residual. U hat is my residual. Okay, and then the interpretation, as I said, I will just give you the sample regression function, everything, and then you have to interpret maybe constant and slope parameters. So look at this example. Wage hat equals 0.9 plus 3.5 years of education, sample regression function. It is still a simple linear regression because there's only one explanatory variable. Okay, when X is 0, the sample regression function predicts that on average, wage is 90 cents. And then slope 3.5 means when years of education X increases by 1 unit a year, the sample regression function predicts that on average, wage would increase by 3 Rand 50 cents. And then X, there must be some variation in the X. So if I collect a sample of data and X is exactly the same for everyone, it is impossible to derive the slope parameter because graphically, you will have a vertical line. Okay, then it is no longer a regression line. Okay, so let me stop here, and then in the next video we will discuss quite a few theoretical concepts, properties of OLS, statistics, and then the assumptions of the regression model. So see you later.